Starting our new unit, we're getting into what's called the binomial theorem as well as probability. We're going to be working with things that are called combinations and permutations. So first, let's take a look at what a combination is, and it's an arrangement where order does not matter. So for example, if I need 3 volunteers to help me carry something, it doesn't matter which order I choose the volunteers, I get the same 3 people to help me carry it. There's a formula for combinations. So if you have n items, so for example, if I have 20 students and I need 3 volunteers, n is 20, that's the total number in the group, and then 3 would be r, that's how many volunteers that I'm choosing. So you may see it expressed right here as NCR, C of course for combination. You may just see it in a set of parentheses with n on the top and r on the bottom. That's the same notation as NCR. And the formula is, in the numerator we have n factorial, in the denominator n minus r quantity factorial times r factorial. There will be some of these that I want you to show by hand, but there is also a button on your calculator that will do combinations for you. Next we have Pascal's triangle. This is a famous triangle, and it's generated using combinations. Now the one thing that's a little bit tricky about Pascal's triangle is that it starts counting as 0. So the first row is row 0, and the first number in each row is generated by using NC0. So remember with Pascal's triangle that you need to start counting at 0. This is an extremely useful triangle. There's tons of applications of it, and we're going to see one of them today. Several properties. First of all, you may have noticed that every row begins and ends with a 1. You may also notice it's symmetric. The second number in each row and the second to last number in each row are the same. And it equals the row number. So that's one of the reasons we start counting at row 0. So notice in row 2, we've got that 2 in the middle. In row 3, we have the 3. In row 4, we see a 4, and so on. The sum of the terms in each row is 2 to the nth power. That's not a property we'll be using today, but it is a property of Pascal's triangle. And as I mentioned, those rows can be generated using combinations. Or if you look at taking 1 plus 2, it equals 3, which is the term kind of halfway between them. 3 plus 3 gives you 6. 1 plus 4 gives you 5. So you can take the previous 2 terms in the row above it, add them together to get the term in the next row. All right, so first we're going to start just by taking a look at few terms in Pascal's triangle. So generating the first 4 terms in row 9. The first term, so we're in row 9, so we start with 9, C0. The first term is actually the 0th term. So when you do that formula, and I'm not going to work that out right now, but we will see it on the assignment, and we can look at it with our warm-up as well. But just to simplify and save a little bit of time in the video, 9C0 is 1, and we already knew that the first term in every row of Pascal's triangle is 1. 9C1 for that second term is 9, and we already knew that as well because the second term in every row matches the row number, and we're in row 9. So then we get on to some that we might need to do the formula for. 9C2 gives us a value of 36. And 9C3 gives us a value of 84. So those are the first 4 terms in row 9 of Pascal's triangle. Next, we're going to take a look at what's called the binomial theorem. So first we're going to start by expanding some simple binomials. So for example, our first one, x plus y to the 0 power. Anything to the 0 power is 1. X plus y to the first power is x plus y. I'm going to throw the coefficients of 1 on there because when you expand a binomial, it relates to Pascal's triangle. The coefficients do, so I want you to see those. When you square x plus y, you get 1x squared plus 2xy plus y squared, or 1y squared. So notice, like I said, those coefficients on each of those, or the constant in the first part, equal the rows in Pascal's triangle. So remember, Pascal's triangle starts 1, 1, 1. Notice those are the coefficients when we raised it to the first power, and that is row 1. The first row was row 0. And then row 2, 1, 2, 1, and those are the coefficients when we expand to x plus y squared. The powers come from the highest power. So notice on the first term we have the highest power, and then the power goes down, and then notice the x is gone on the last term. For that y, the one that was the second term, it's backwards. So notice it started on the end with the highest power, went down 1, and then it disappeared on the first term. So we're going to use all of these properties to do what's called expanding a binomial. So raising something to the 6th power, for example, you could FOIL it out 6 times, which does not get fun after the second time you FOILed, or we can use the shortcut given to us by Pascal. So what I do is I like to organize my work in a box, and you will always have 3 rows. 1 for the coefficient, and those come from Pascal's triangle. 1 row from the first term, so that's going to be our x row, and the last row for the last term, so that'll be our 3. You need 1 more column than the power. So remember, Pascal's triangle, it starts counting at 0, so there's actually 7 terms in row 6. So we need 7 boxes, and I didn't give myself a whole lot of room here. All right, so in the top row, again, these are going to be the coefficients for each term, and they're coming from the 6th row of Pascal's triangle. So you have 2 options. You can use the combinations to generate them, or you can memorize the first few rows of Pascal's triangle. And since I won't be asking you to expand something to the 20th power, that would take you forever, it may be helpful to just memorize the first few rows of Pascal's triangle. So the 6th row goes 1, 6, 15, 20, and then it's symmetric back down to 15, 6, 1. Next, we are going to take the x, and we are going to start by raising it to the highest power. So 6, if my stylus will work. I still haven't gotten my new styluses in. And then the power decreases on each consecutive term. And the last box should be blank. It's technically x to the 0 power, which is just 1, so we don't really need to write that. And then we start on the end this time. So this time I'm starting on the right, and I'm going to work my way forwards. And we start with that 3 to the highest power, and then we decrease the power as we work our way forward. And once you're done with that, again, that first box should be empty. 3 to the 0 power is 1. We're going to multiply vertically to get each term in our final expansion. So my first term will be 1 times x to the 6th, or just x to the 6th. My second term will be 6 times x to the 5th times 3. 6 times 3, of course, gives us 18, so we have 18x to the 5th. My next term, we're going to have 15 times 3 squared. 15 times 9 gives us 135 x to the 4th. Next, we'll have 20 times 3 cubed. 20 times 27 is 540 x cubed. Then our next column, we have 15 times 3 to the 4th, which gives us 1,1215 x squared. Next, we've got that 6 times 3 to the 5th, which gives us 1,458 times x. And lastly, we've got 1 times 3 to the 6th, which is 729. Let's take a look at that one more time. This time we have a coefficient on both variables. We have 2 variables. We have a coefficient on both variables, and it's subtraction instead of addition. So we're going to start by setting up our box. Remember, always 3 rows. The first row is for the coefficient, the second row is for that first term, and the third row is for the second term. And then you need 1 more column than the power. So we have a power of 4, so we need 5 columns. All right, in the first row go the coefficients of Pascal's triangle, in this case in row 4. So in row 4 we have 1, 4, 6, 4, 1. And then we're going to take that whole 2x term. So you will be raising 2 to the power as well as x. So we're going to start with it to the 4th power, 3rd power, and then we're going to work our way down. All right, so for the subtraction, you have a couple of options. One option is to know that every other term in the expansion will flip signs. The option that I recommend is keeping that negative. It's a coefficient of -4, so think about it as adding -4y instead of subtracting 4y. So we've got -4 to the highest power of 4, and then we're going to work our way down. And again, we'll have two boxes blank in each of the second and third row. And then we're going to multiply vertically. So when we multiply our first column, we've got 1 times 2 to the 4th, which is 16x to the 4th. In the second row, we have 4 times 2 cubed times -4, which gives us -128 x cubed y. In that third column, we've got 6 times 2 squared times -4 squared, which becomes a positive 384 x squared y squared. In the next column, we've got 4 times 2 times -4 cubed, which is a -512 x y cubed. And then in our final column, we've got -4 to the 4th, which is positive 256 y to the 4th.